Hello everyone, welcome back to my video. In this video we're going to talk about how you can decompile an APK file in an industrial project. So if you end up watching this video, you probably know what is decompiling and recompiling of an APK files, and also you probably know about the tools like APK tool and some other online open source tools which is used for decompiling an APK file. So we are not going to talk about that again in this video, but rather we're going to talk about how you can actually re-import those decompiled files in the industrial project and make it work again. So the process is actually pretty simple, and if you know Android development, you can actually do that pretty easy. But there are some problems with this process, and there are some things possible. There are some things that are impossible to do in this conversion process. So we are going to discuss about that. And before I get into that, I want to give a disclaimer that anything that you are doing is at your own willing, and I will not be responsible for anything that you do. So let's get into the video. So I made a demo project in Anda Studio to demonstrate how we can actually decompile APK files and recover it in the Anda Studio. So one of the as you can see, I created this Anda Studio project, and it has some like around 7 classes in it, and it has around 7 layouts including fragments and stuffs. So what we're going to do now is I'm just gonna build the APK, and what I will do is I will go to this website, decompiler website, and I will upload that built APK. Let me open it. Yeah, I will upload this APK to this website. What it will do is it will basically decompile that APK and will give us the resources and sources. Resources will contain the XML files and PNGs, JPEGs, whatever the stuff related to the layouts and resources. It will contain inside this folder, and sources will contain all the Java classes, only the Java classes, nothing else. It will include all the third-party libraries as well. As you can see, it has AndiRX SDK, and here's the package, core package of our app, demo app. If you see that we have the project with the app/desktop package within that, and as you can see, it is here. And if you go there, you can see that there's a main activity, and we have that as well here. So if you open that main activity, you will see almost everything matches with the originally written Java code. Yeah, almost it will actually when you actually decompile the APK, it will match almost 90% if it is not obfuscated. That's another topic. I will talk about that in this video, and probably that's the main point of this video. So as you can see, I just replaced the code of main activity from the original written main activity to the decompiled one, and there's no errors. And the point to note here is that when you decompile an APK and try to import the classes into an industrial project, you're not going to have a clean code like this. So I don't have any problem or error with this lines of codes, because this is very simple class, and that doesn't have much functions. Like there's nothing at all in this main activity, just basic implementation. So that's why it actually decompile it pretty easily. And the same way, we just have to import all these classes from the decompiled sources. You can ignore the data binding package, because that's a generated classes, not part of the actual written code. You should probably know what it is if you are familiar with Android development. So within our UI slash gallery package, we have a gallery fragment and a gallery view model. But we do have another one generated class here. This is basically generated by the decompiler, which will not be present in the actual source code. That is the thing that we will see very often when we try to decompile an APK file. But if you go back to the gallery fragment class and copy the stuffs, and by the way, when you do this, you just have to create this package. Just imagine like you are creating a new package project with the same package. I mean, by same package, I meant what I meant is, you can see that in here, if you cannot identify which is the core package of that particular APK, you just go to the resources and go to the item manifest, and in there look for the package name. And by the way, yeah, when you create a new industry project, like here, you select the node activity and give the same package, exactly the same package as you as the APK that you want to recreate. For example, app slash test app. I mean, not the slash, it's dot. Sorry for that. You can give whatever the name that you want, and for the minimum SDK, you can choose the same minimum SDK as present in the manifest, which is 19. That's fine. You can even increase it or decrease it as per your requirement, and make sure to select the language Java if it was default to the Kotlin. And I just didn't create the new project because there is nothing useful by creating new project, because we can actually replace the classes, and I will show you that. I'm just telling you that when you want to actually create a new project from the decompile code, you just have to create the new project like that. And let's come back again here, and as you can see, this this part of the code line, line of the code requires that class gallery fragment $external synthetic lambda 0, which we have seen inside the package here. So we just copy this, and if you want, we can just paste it here. It will automatically create the class file when you paste it, or else you can just press right click and create a new Java class, and the array is gone, right? So it's not it might not be a properly designed code, like when you actually see the code, original source code, it is very clean, but decompiled code will not look clean most of the time. And the same way we're going to replace this class as well. Remember, you have to create all these classes separately, or you just have to copy paste these classes when you download from here. You just press the download zip button, and it will download all the decompiled files. So then you can go to this go to the respective package source classes folder, and copy all those files and paste it in here. I just didn't download it. To demonstrate, I'm just copying the lines of code and pasting it here. Basically, you get what I'm talking about, right? So you probably will get it, because if you know a little bit of Android development, you probably will understand what I'm actually talking about here. Well, if you're not familiar with Android development, that's another topic, and but this practice actually need a little bit of development experience, as it involves creating a project and importing third-party libraries via Gradle and a lot of other stuffs too. So if we go to the home fragment and copy this, I'm just gonna comment all this out and paste it here. The same way I'm going to do for home view model 2. Just gonna delete it and paste it, and you probably won't notice the difference between the original class and the decompiled class. As you can see here, everything is exactly the same, nothing difference. And if you ask me that, it will not be consistent at all. It will change depending on the APK, and there are lots of other stuffs involved in this process. So don't expect this decompiler to produce the uh, picture perfect, I mean 100% actual source code for you. It will never do that for all APKs. Only for some basic bare minimum and small APKs or APKs with not much of a code, it will do the perfect job. Let's go to the slideshow, and we're doing the exact same thing again. And that's it. We copied all the packages, and we ignore the data binding, as I told already, because data binding is generated classes, not the one that is actually written. If you know about view models and stuff, then I mean the data binding stuff, you probably know about that. And this R class and build config class, you can ignore them, because that also, those two classes also generated by the studio, and the studio, not written by the developer. So if you go ahead and try to run this app, it will run just fine, because we already have the layout files of the original code. We didn't replace that yet, and but actually we just replaced the class files, and that actually worked fine, as you can see here. So now let's try replacing all those layout files. And you probably don't know what are the original layout files present in the APK files, right? So you can easily identify if you go into the resources and arrays folder, and inside the layout folder you can see list of all the XML layout files, but most of them are generated like this: ABC and design layout and M3 and material and MTRL. These layouts are automatically generated by the studio, because these layout files present in um, libraries, third-party libraries. Basically, this design navigation and M3, these are the part of Google's material design library package, which we already importing with via the build upgrader. As you can see, yeah, this library is is still responsible for all this material stuff and layouts. And as you can see, view binding is enabled, and that's why we seen that data binding folder in the sources area. So in here you can just ignore all these auto generated layouts. You can there are standard stuffs that you can ignore, which is this ABC and design. If you see a layout XML file with the same prefix like design hyphen and underscore and ABC underscore, you can ignore them, and you can come here and you can actually identify those by going here. In this version we are using data binding, right? So we will not see which layout file we have to choose from. So you just have to go ahead and find that out from here by ignoring all those auto-generated layouts. So if we ignore all this, we are left with a fragment gallery, fragment home, fragment slicer, and activity main. Activity main is probably the main layout for that main activity, right? Here, the main screen. So what we'll do is we'll just copy this and go back here and make sure to create the activity main, because its actual name is activity main.xml. So I click on this layout folder and create the layout resources and the activity main. We don't want to do that again. We have already we have that already, so we're just going to copy and replace it, and there are no errors, so we can move ahead and with another layout file. So I'm not gonna copy entire thing because it's gonna be perfect for when it comes to the layer traces. If you want, you can just use the APK tool to get the layered files and these values like styles, themes, strings, etc. Copying the content main. So I'm just gonna leave these two as it is. Yeah. So there are some issues with layered files, and so we basically need to fix them. Like for example, as you can see, the version layer does have this accent bar, but when we paste it, we don't have that. So we just try to compile and see how it looks in the actual app. It doesn't compile. It throws some error. So let's see if we can fix that. Yeah, we just have to the constraint attributes are wrong here. 0 is parent. And let's try to compile it again. Yeah, it does compile and also runs fine. So this is it. This is how you actually decompile and restore the decompiled files in the industry project. Oh, and also you have to make sure to replace the manifest file. So let me just do that too. And yeah, of course, you have to go through all these drawable folders and map, which will mostly contain the icon for the project. And inside values folder, you'll see styles, strings, and you got the menu items, and you got the colors. You just go into respective XML files and copy the stuffs and ignore the stuff that you don't want, and you the stuff that you suspect as generated by the third-party library, you can just ignore them. So in the manifest, you just copy all this stuff and paste, and you'll be fine. So as you can see, I just copied the manifest and replaced it, and it just runs fine. I'm able to build the APK just fine. That. So we're having some issues with the main activity main binding, because I think there is some issue with the generated main binding. So we can just ignore them and try to rebuild it. If it rebuild, then it's just lint error, so you don't need to bother about that. We'll just build just fine. As you can see, was able to run. Yes, builds the APK and runs just fine, and the S goes away. This happened because I touched the activity main layout XML, right? So it triggered something in a generator class, and that's why it displayed as an error. That's fine. So basically, this process will work if you have a normal APK. By the word normal APK, what I mean is the APK which does not use a lot of classes and does not have a lot of modern Java features such as lambdas and more, and also doesn't use ProGuard. In the new Android Studios, it is called Orate. Orate does the code obfuscation and resources deletion when the resources are not used. So what those stuff actually do is when the APK use most of the APKs, if you go to the Play Store and take any of the APK and try to decompile it, you cannot see a clean code like this. You cannot see clean package names. You cannot see clean class names like this, and also you cannot see clean function names and variable names, because most of the apps these days will use ProGuard, because by default and Studio will obfuscate the Android app when the final APK was built using R8 obfuscator. For example, I have an test case APK. Using this that test case APK, I will show you how it will actually look for when you try to decompile any random APK. So yeah, like I said earlier, you cannot just go ahead and reverse engineer any APK that you want, because there are lots of issues with it. And also you cannot just go ahead and decompile WhatsApp or Facebook APK or even a Google or YouTube APK, because those steps are not as easy as like you think. And also sometimes it's just impossible, because not all APKs are built similar way, because some nowadays most of the developers use Flutter. The Flutter is impossible to decompile, and actually not impossible but possible, but it's just not easy. It's not worth the time at all. And some APKs will JNI, which will prevent also most of the reverse engineering. And also actually out of all those things, just the obfuscation is enough to prevent decompilation and reverse engineering. But that doesn't mean it is impossible to reverse engineer this obfuscated APKs. It is actually possible if you are experienced enough. So it is currently decompiling that APK which I uploaded. I'll show you how it will actually look. Oh, in the meantime, I want to let you know, I will leave my Fiverr link in the pinned comment and description. So if you want recover your lost source code, or want to recover the source code of an APK file that you want, and you can hit me on Fiverr, and I will do it for some price. Yeah, it's not a free service that I'm doing, but it will be affordable for sure. I will actually work on APKs that are obfuscated as well, which I'm going to show you how it will look. So I'm not encouraging to decompile someone else's APK and use it for your project. I'm just giving a service for the lost APKs. Like if you lost the source code of your APK, then I can just recover and recreate the project in Android Studio. But first you need to give me the APK file to analyze and check for the possibilities. Just like I said earlier, not all APKs are possible to reverse engineer and recreate the project. I think it's taking a lot of time than you saw. Okay, let me go ahead and use a different decompiler. Yes, it just takes too much of time. Sorry, I didn't select the file at all. Okay, I don't know why it takes too longer. Let's see which decompiler finished the job first. Obviously, it depends on their service, And yeah, if you are uncomfortable using these online services, you can just go ahead and yeah, this website decompiled it first, so I'm just gonna close that. You can obviously just use the open source tools to do this job. So as you can see here, I have this case2 APK in which we don't see clean source code like we are seeing in here. So if we go to the sources folder in this appdebug.apk, which we built from demo project, we are seeing clean package names and clean class names and clean function and variable names. But if we take this APK for example, we don't see that here. Everything was randomized, like A, B, C, everything will be randomized. This is to save the size of the APK as well as protect the APK from reverse engineering, obviously. So if we go inside some random classes, we will see that also the method names and variable names are all obfuscated very heavily. So in this case, most of the time apps like this are almost impossible, but at the same time not impossible also. We can actually recover if we are good enough. We just have to find the references inside the classes, and we just have to stitch all together and make a new project based on the logics and stuffs that we find with the linking. So the process is exactly the same as we did here. We just find the reference using the Android manifest. We just go ahead and go to the resources and open the manifest and see what are the references linked with our classes. For example, the launcher class, and we go here and find for that specific class, and from there we just link everything based on the errors that we will see when we import. So if you are new to this stuff, then you probably cannot reverse engineer that use the APK that uses a proguard. So in that case, if you lost the code of your APKs, and if you had obfuscated the APK with proguard, and if it stuck with stuck in the process, so you can hit me on Fiverr and then I can do the job for you. And like I said, I will not be responsible for anything that you do with the recovered source code. That's totally depends on you, and I don't encourage any of the copyright infringement or anything like that. So just like as I said, everything is at your own risk and own responsibility. So that's it for this video. So if you have any doubts, make sure to comment on my video, so I will try to reply to that comment as soon as possible. And yeah, sorry for my bad English, because English obviously not my native language, so I struggle a lot while speaking. So I hope you get it. Yeah. So thank you so much for watching.